So like I mentioned before, we cannot prove this in the same fashion that we've proven a lot of other things, just because we don't have the theorems and tools to get there yet. But we can definitely informally show why this works using some coordinate geometry, right? And coordinate geometry is just when we use our geometry skills combined with a coordinate system. So it usually encompasses our geometry skills and some algebra skills. Okay, so here we go. So we want to, we're given that D is the midpoint of AC, E is the midpoint of CB, and we want to show that DE is parallel to AB in that case, and that DE is 1/2 of AB in those. If these are true, then let's see if those are true. Okay, so let's start by finding the midpoints, right? So remember our midpoint formula. Let's see here. Midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2, right? So basically just finding the averages of each of the coordinates, right? Basically what we're doing. And so let's find D first. So D is going to be, D is the midpoint of AC, right? So that means that these are our coordinate points. So we'll call the C's the 1. So x1, y1 there, and then this will be x1, x2, y2. Okay, so it'll be 0 plus 4 over 2 for the x's, and then 0 plus 6 over 2 for the y's, which equals, so this is 4 over 2, which is 2, and this is 6 over 2, which is 3. All right, hopefully that was pretty straightforward for everyone. So then E is the midpoint of CB, right? So here's CB, and so E is the midpoint there, and so let's use our formula to find that. So E is going to be, we'll do these as our 2's and these as our 1's. So we'll say 0 plus 6 over 2 and 0 plus 0 over 2. So E6 over 2 is 3 and 0 over 2 is 0. All right, so let's plot these points. So D is 2, 3. So x equals 2, y equals 3 is right here. So that's point D. And then E is 3, 0, which is 1, 2, 3 right there. All right. And so now we have a new, we have the two midpoints. Now we can connect those to make the segment DE, right? All right. So now what we want to show is this segment DE parallel to AB, right? That's one question. And is DE, this segment, half of the length of AB? Okay, so those are the two things that we want to figure out. All right, so let's start with the parallel. So to find these are parallel lines, remember now we're going to use some algebra skills. So how do we know how do we know that lines are parallel on a coordinate plane? And it goes back to linear functions, right? We know if they're parallel if they have the same slope, right? So what we can do is we can find the slope of each of those lines, DE and AB, those segments, and we can find, we can see if they're the same. If they're the same, that means they're parallel. If the slopes are not the same, that means they're not parallel. Okay, so let's do that. So, so I want to show, is DE parallel with AB, right? This is what we're trying to determine. And so first we'll find the slope. We use M for slope, right? I'm going to find the slope of DE. So that's y2. We'll call these the 2's and these the 1's. So we'll do y2 minus y1, 3 minus 0, over x2 minus x1. Oh, I did that backwards, right? It's actually x2 minus x1 is the way I originally said it. So it'll be 2 minus 3. So it'd be 3 over 2 minus 3 is negative 1. So that'll be negative 3 there. All right, so now we're going to find the slope of AB, segment AB. And so we want to do the same thing, except we'll call these our 2's and these our 1's. All right, and so y2 minus y1 would be 6 minus 0. And then in the denominator, we'll do x2 minus x1, so it'll be 4 minus 6. So 6 minus 0 is 6. 4 minus 6 is negative 2. 6 divided by negative 2 is negative 3. So that means the slopes are the same, which means that these are, in fact, parallel, right? So we've just proven that these lines are parallel. All right, one last one. Now we have to prove that DE is 1/2 of AB, right? And so in order to do that, we have to find the length of each of those segments, right? And the way we find length is with our distance formula. So let me set this up. Is this true? That's what we're trying to determine. And so our distance formula, if you recall, is x2 minus x1 quantity squared plus y2 minus y1 quantity squared, and all underneath the square root, right? So the square root of all that. Remember, it's based on the Pythagorean theorem, right? All right. So now we're just going to evaluate. Let's find the length DE. Okay, so remember that's D and E without the bar over it means the length. So that's going to equal x2 minus x1. So we'll call these the 2's and these the 1's. So it's going to be 2 minus 3 quantity squared plus 3 minus 0 quantity squared, all underneath the square root. Okay, and so then we get 2 minus 3 is negative 1. Negative 1 squared is 1. Let me actually do this right below. So we get negative 1 squared plus 3 squared, right? And so 1 squared is negative 1 squared is 1, positive 1. 3 squared is 9. So 1 plus 9 is 10. So we get root 10. And that can't be reduced, right? So we'll just leave it as it is. All right. So next, let's find AB. We'll do the same thing. So we'll call these our 2's and these are 1's. So we'll do x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And so this will turn into negative 2 squared plus 6 squared. And so negative 2 squared is 4. 6 squared is 36. 4 plus 36 is 40. So we have root 40, right? And we can simplify that, right? Root 10 we couldn't simplify because all it goes in is a 2 and a 5, so there's nothing to come out. There's no perfect squares there. But root 40, that can be written as square root of 4 times square root of 10, right? And square root of 4 is 2. So this is 2 root 10. If you remember back to our simplifying radical days, right? So 2 root 10. So you can see pretty clearly 2 root 10 is double root 10, right? And so that means that this is true, that AB is double DE. Or in other words, DE is half of AB. Okay? All right, and you can even put it into that equation if you want. You can put root 10. Does that equal 1/2 times AB, which is 2 root 10? And that's true, right? 1/2 times 2 is 1, so they cancel out. And you get root 10 equals root 10. All right, so that's an informal proof or presentation of why or how this works, right? How the mid-segment theorem works.